derivative of parametric function. Before that one, I will review about the corresponding last lecture which we had always taken on, that is those functions which are higher order derivatives. That means second order derivative. In second order derivative, when we have studied about the derivatives y is equal to f of x function, when you differentiate with respect to x, then the first order derivative means first derivative. When we can find the derivative of the function first time, that is called as the first order derivative. Second, we had seen that is second order derivative means what is the differentiated part of the original function, that is the f dash x, means dy upon dx. Then again we have to take that is the derivative with respect to x, hence therefore we have to find the derivative of second order derivative. In second order derivative, the presentation of derivative of dy by dx means d dx of dy by dx is equal to d square y upon dx. Means that is represented in this way. We have seen d square y upon dx. What is the meaning of this part? Derivative of dy by dx with respect to x means second order derivative of y. It is represented in this way. In last lecture also we had discussed about those examples which are always appears for the board exam as well as the in other exams. Those are priority for that one is show that examples are there. We have discussed about those show that examples. You are also studying some practice also of that part. Now here parametric function is also one type of function. Parametric function means it is not a special main function. Parametric function means therefore when two functions are given with same domain and therefore we have to take that is a different type. म्हणजे उदाहरण कसं आहे, here y is equal to g of x, y is equal to g of x or g of t. I can take here f of t, y is equal to f of t, and second function that is x is equal to g of t. Means look here, what is the observation here? Y is equal to f of t is the one function, x is equal to g of t is the other one function. Here domain is the same, but functions are different. Domain is the same, functions are different. Such type of function is called as a parametric function, and therefore what is the domain t symbolized here? That t is called as a parameter. Means the containing parameter which can show the two functions different. So these functions are called as a parametric functions. And if you have to find the derivative of this type of functions, first we have to find the dy upon dt because t is the domain. So differentiate with y with respect to t, dy upon dt. Second function is equal to x is equal to g of t. So you can take here derivative of x with respect to t is dx upon dt, that is equal to, we can get here g dash t and here f dash t. Means we can exist the derivative dy upon dt as well as dx upon dt. Suppose this function is always undergoing the corresponding main domain, that is x. So we have to exist that in the dy upon dx. Now there is a special property, means theorem, which is always included in your syllabus, which is always present in the textbook. That theorem is in this way: dy upon dx is equal to, means here dy upon dx is equal to dy upon dt divided by dx upon dt. Here dx upon dt is not equal to 0. This is a theorem. So what is the total parametric functions theorem? If y is equal to f of t and x is equal to g of t, and those functions are differentiable with respect to x, and the parameter is t is the parameter, then dy upon dx is equal to dy upon dt divided by dx upon dt. Very simple methodology is always present in this part. Dx upon dt is not equal to 0 means that derivative is not 0. So otherwise the function should be undefined, or that is a result will be undefined value. Means here that theorem we have to use in this part. So how to solve these examples? I will show these examples how to show. I will take one example on this part. That example is in this way. Therefore, if x is equal to a in bracket t minus sin t, and second function y is equal to a in bracket 1 minus cos t, then we have to find dy upon dx. What is the question mark? Now this is there are two functions for that. X is equal to a in bracket t minus sin t, y is equal to a in bracket 1 minus cos t. Now what you can see here, this is one type of function, second type of function, but parameter is same. So t is the parameter. Parameter means what? This parameter means in dimensional geometry, 3-dimensional geometry, a certain location where you can set it. Then therefore, according to 3-dimensional geometry, we have to fix the location of that one point, and that point's position, which is shown from x-axis, y-axis, and z-axis also. That point also shows the position in different positions, but that is a distance between the origin. Distance from the origin is almost same. So they can show the location different, but that is the nature of the function should be same. So such type of functions which is called as a parameter function. Parameter means the replacement from one place to the another place. Position is different, but nature of the function is same. So here we have taken that function with respect to t, this function also with respect to t, but names are different. Now I can take first function in this way. X is equal to a in bracket t minus sin t. Now t is the parameter, so you can differentiate with respect to t. Now dx by dt. What is differentiation? dx upon dt. A constant value, a is coefficient of 1 plus 1 t minus sin t. This is expression, a is coefficient. Now t differentiate with respect to t, 1 minus sin t differentiate with respect to t, that is equal to cos t. Now first differentiation we have here. Second is in this way, y is equal to a in bracket 1 minus cos t. Now differentiate with respect to x. What you can get here? dy upon dt is equal to a constant one. This is 1 is also constant, derivative 0 minus cos t derivative minus sin t. That minus sin t and this minus plus sin t. So you can get here a sin t. Parametric differentiation is here. We have differentiated x with respect to t, y with respect to t. Now what is the result of the parametric function? And theorem can show here dy upon dx is equal to dy upon dt divided by dx upon dt. Now substitute divided by what is dx by dt? A in bracket 1 minus cos t. 1 minus cos t. Here differentiation is completed, but we can easily simplify it. It is possible. If it is possible, then we can simplify this. Half angle property we can use here. Sin t means what? 2 sin t by 2 into cos t by 2. We know that sin 2x is equal to 2 sin x into cos x. But when you can exist it, 2 sin t by 2 into cos t by 2 and divided by, we know that cos converted formula of 1 minus cos 2 theta is equal to 2 sin square theta. Therefore 1 minus cos t is equal to 2 sin square t by 2. So what you can exist here? The 2 gets cancelled, 1 sin gets cancelled here. So what is the result over here? dy upon dx is nothing but is equal to, this is cos t by 2. Here 1 sin t by 2 gets cancelled, sin t by 2 remains here. So cos t by 2 divided by sin t by 2. So you can get cos upon sin is equal to cot. So cot t by 2, and that is a dy upon dx, which is a derivative of parametric function. Now in this parametric function, such type of differentiation we have to take. So dy upon dx exists here, dy upon dt divided by dt. according to the parametric function formula, dy by dx is equal to dy upon dt divided by dx upon dt. Now we have existed with these values and substituted here, and after simplification we have got this. Similar way we can solve another one example. Sin t into cos 2t into cos 2t. Y is equal to cos t into sin 2t. And here we have to find dy by dx. dy upon dx at t is equal to pi by 4. Now here this is also one parametric function, but here we have to exist the derivative of this dy upon dx at t is equal to pi by 4 because t is a parameter, and parametric function at particular point t is equal to pi by 4. So we can get a particular derivative of this parametric function. Now here this parametric function, it is easy to solve this one. Now again we can solve it this way. Take that is the x is equal to sin t into cos 2t. Correct? Differentiate with respect to t. Differentiate with respect to t. Now we can get here dx upon dt is equal to. Now there are two functions are there, sin t and cos 2t. We can use the product rule of derivative. You can get here sin t into derivative of cos 2t is equal to minus sin 2t. Into chain rule again, sin cos 2t, 2t is also one function. So differentiation of 2t is equal to 2 plus cos 2t into derivative of sin t is equal to cos t. Now look, concentrate again. Sin t into derivative of cos 2t is equal to minus sin 2t into derivative of 2t is equal to 2 plus cos 2t into derivative of sin t is equal to cos 2. Here we are using the chain rule of the derivative form. Now simplify here, minus 2 sin 2t into sin t. 2 sin 2t into sin t. This is first one. And here plus cos 2t into cos t. Now listen here. This is we have taken in this way. Minus 2 sin 2t into sin t plus cos 2t into cos t. Similar way. Now we have to differentiate this also. Don't simplify this one because we have to find a particular derivative. There is no need of simplification because of particular derivative directly then we can find the dy upon dx by dy upon dt divided by dx by dt. Directly we can substitute the value of t is equal to pi by 4 and we can exist the particular derivative of this function. Now I can exist the derivative of this part y is equal to cos t into sin 2t. Now differentiate with respect to t. Therefore dy upon dt is equal to, again product rule, cos t into sin 2t derivative cos 2t into chain rule 2t derivative 2 plus sin 2t into derivative of cos t is equal to minus sin t. Now simplify. 2 cos t cos 2t into cos t with a plus into minus here sin 2t into sin t. Because we have taken here minus, this plus into minus. Now dy upon dx we know that dy upon dx is equal to dy upon dt divided by dx upon dt. Dy upon dt divided by dx by dt. I can directly write here this part here. Dy upon dt means what? 2 cos 2t into cos t minus sin 2t into sin t. This is always dy upon dt divided by, this is dx by dt. We can take here in this way. First I will write this one. Cos 2t into cos t, cos 2t plus, and this is minus 2 sin 2t into sin t. Don't try to cancel this one because this minus sign This is total expression is there, total expression is there. Some students also use the silly mistake in this part. They can get cancelled about this, not cancel. This is the expression. Expression directly in this way cannot cancel. So now we can find here dy upon dx at t is equal to pi by 4. Now substitute value here. 2 into, no concentrate here, 2 into pi by 4 means pi by 2. So cos pi by 2. Cos pi by 4 minus sin 2 into pi by 4 means pi by 2 into sin pi by 4 divided by, again here cos 2 into pi by 4 pi by 2 cos pi by 2 into cos pi by 4 minus 2 sin 2 into pi by 4 that is equal to pi by 2 into sin pi by 4. Now if you perfect about the corresponding values of trigonometric functions, then I can directly say here what is the value of dy upon dx. Dy by dx at t is equal to 4 pi by 4 is equal to pi by 2 cos pi by 2 is equal to 0. So this gets complete 0. Means here minus sin pi by 2 is equal to 1. This is 1. Sin pi by 4 is equal to 1 upon root 2. That is 1 upon root 2 divided by cos pi by 2 0. 0 means this part is 0. Minus this minus 2 into sin pi by 2. Sin pi by 2 is equal to 1. It's 2 into sin pi by 4 is equal to 1 by root 2. So this gets cancelled. Minus divided by minus plus 2. We can get the value is equal to half. Okay. The next two examples on this part is y is equal to x square plus 1 and b is equal to under root of 1 plus x square. Here we are finding dy upon dv. Such type of example appears also for board exam. Now only nature is separate here. Y and b are the two separate functions and parameter is x. Now identify the what is the parameter here. So parameter is equal to x. So y is equal to x square plus 1. Very simple example I will take. Now this is a differentiate with respect to x. Differentiate with respect to x. Familiar example for us. Now differentiate with respect to x. What is the here? Dy upon dx is equal to derivative of x square is equal to 2x, constant derivative 0. Where exists the value. Now second one b is equal to under root of 1 plus x square. We have got here 1 plus x square. Now it is derivative of with respect to x. Differentiate with respect to x. Now dv upon dx. dv upon dx is equal to first that is under root of 1. Derivative of under root 1 upon 2 root of 1 plus x square into chain rule. Under root part is expression that is 1 plus x square. So again we can find the derivative of chain rule. Derivative of 1 plus x square by chain rule. 1 derivative 0 x square that is 2x. Existed value is 2 1 to cancel. So x upon under root of 1 plus x square that is the final derivative of dv upon dx. But we have to find dy upon dv. So parametric form is in this way. There is a dy upon dv is equal to dy upon dx divided by dv upon dx, that is parametric. Substitute what are the existing derivatives here. What is dy upon dx, that is 2x, and what is the derivative here, that is dv upon dx is equal to x under root of 1 plus x square. Now this gets to be simplified. That is a reciprocal of this part. So 2x under root of 1 plus x square divided by x. X gets cancelled. So dy upon dv we have got here that is equal to that is 2 under root of 1 plus x square. Final derivative is understood. Now that is very simple example. Observation, analysis. Every time you have to make the concept of the derivative of this part. Separate parameter should be there, but don't get confusion about this. So this way, this is example, very simple example I will show here. I have solved. Now second example is confused. How it is confused, I will explain that one. You will listen and look that carefully. Second example is in this way. First, it is simple. Now x is equal to 80 square, comma y is equal to 280. These are the two functions. These functions x and y, these are the two functions. The parameter is t, which therefore we have to differentiate corresponding those functions with respect to t. Now, therefore I will take simultaneously x is equal to 80 square. What is the derivative? dx upon dt is differentiate with respect to t. With respect to t. So what we can get here? dx upon dt is equal to a constant value. What is t square? T square is equal to, that is the power function 2t. Proper way, 280 is the derivative of the corresponding function. Now y will be here, y is equal to 280. And here, differentiate with respect to t. So you can get here, dy upon dt is equal to 2a, derivative of t with respect to t is equal to 1. So we have written here. What is the parametric rule? Parametric rule is this way, dy upon dx is equal to dy upon dt divided by dx upon dt, where dx upon dt is not equal to 0. Now, dy upon dt upon dx by dt. Okay. Substituting this value and you can get existing value dy upon dx. There is no problem up to here, 280. What is dy upon dt? d2a, and that is your dx by dt. 280, so we can get cancel 1 upon t dy upon dx. Now confusion point is from here. Now dy upon dx is there, and if you have to find the derivative of dy upon dx with respect to now x, existing derivative of dy by dx with respect to x is nothing but it is a d square y by dx. But look here. This dy upon dx we are differentiating now with respect to x. Otherwise we cannot exist the segment or derivative of with respect to x. But parameter is t. So how to differentiate? Differentiate with respect to t. This is differentiated part. So many students get confusion about this one. Now look. dy by dx, derivative of dy by dx is equal to d square y upon dx square. Now we have got the derivative of dy upon dx with respect to x, because otherwise you cannot exist this derivative. Now 1 upon t, according to the standard derivatives, 1 upon t derivative is equal to minus 1 upon t square. But t is a parameter and we are differentiating this function of t with respect to x. So we have to differentiate 1 upon t derivative minus 1 upon t square. But chain rule, t is also one function, monomial function with respect to x. So we can get here dt upon dx. Means here derivative of t is equal to dt upon dx. Similar way, when we can take y square, derivative of y square is equal to 2y divided by dx. Why divided by dx? Because y derivative with respect to x. Similar way, 1 upon t derivative minus 1 upon t square, and derivative of t with respect to x is equal to dx by dt. Now again simplify now this one. The square y upon dx square is equal to minus 1 upon t square. What is dt by dx? Here look here. dx by dt we are existing here. dx upon dt, that is statement number I will give 1. Now concentrate on the statement number 1. dx upon dt is equal to twice dt. So reciprocal of this one, dt by dx, that is means we can take the reciprocal of this part, that is equal to 1 upon 280. 1 upon t square into 1 upon 280. Now what is here? 280 means what? 280 means y. 280 means what? Y. Minus 1 upon t square into 1 upon y. What is 1 upon t square? 1 upon t square. 1 upon t means what? This one. dy upon dx. So 1 upon t square, dx upon dy. सो वॉट एव्हर वी कन्सिडर टुगेदर. आता मायनस 1 अपॉन टी स्क्वेअर जो आहे तो इथं आहे आणि मायनस 1 अपॉन टी म्हणजेच कोण आहे इथं 1 अपॉन टी वेगळं केलं तर डेरिव्हेटिव्ह येऊ शकतो. पण याच्यामध्ये ऍडजस्ट करूया. बघा एक फंक्शन आहे, हे फंक्शनचं एक वेगळं आन्सर जेईच्या किंवा नीटच्या एमसीक्यूच्या पद्धतीने वेगळ्या पद्धतीने काढलेलं आहे. ते कसं काढलेलं आहे आता मी थोडंसं पुसतो आणि इथं एक ऍडजस्ट करतो का मायनस इथं मल्टिप्लाइंग बाय ए टू न्यूमरेटर अँड डिनॉमिनेटर ए स्क्वेअर इंटू ट्वाइस ए. करेक्ट, बरोबर आहे. हे 1 अपॉन ट्वाइस टी हे कशावर आलं आहे dx बाय dy dt आहे. इथं dy dt बाय dx आहे, इथं dx बाय dt आहे. त्याचा रेसिप्रोकल म्हणजे 1 अपॉन 2 it is, तो आपण इथे सबस्टिट्यूट केला. वी हॅव सबस्टिट्यूटेड इन दिस वे. मायनस 1 अपॉन डी स्क्वेअर I adjusted a to numerator and denominator, multiplying a to n and d. What you can exist here? Minus a divided by. Oh, it is square. It is square is equal to x and twice it is equal to y. So I can say here x y. Correct? Now cross multiplying x y into d square y upon dx square is equal to minus a and x y d square y upon dx square plus a is equal to 0. आता हे तुम्हाला कसं आहे? Why I had told this one? Because in one exam MCQ which is always appeared in the MSc exam, that time they had always given same example in this way. In board exam there is no need of second order differentiation after that step. This step is last one. But they have molded the corresponding question. And they had always told us that ask the question in this way: find xy d square y by dx square. That is answer of minus. So in that option minus a was there. In second one, in board exam, same example appeared in this way: if x is equal to 80 square and y is equal to twice 80, then show that xy d square y by dx square plus a is equal to 0. So this example always appears for the board exam as well as in the MCQ system in different ways. Understood? Then these are examples are always we had seen in the parametric form. Such type of examples also we can see more examples in this parametric form. After up to in this all this type of the examples which are always in for different type of the functions, then here you have studied different types. Now easily you have to be differentiate. Very simple chapter should be there. Now simultaneously you can solve this example. When you can solve this example, I will simultaneously show these examples. If you crop this example and send me for as a doubt, I will explain and I will also send it on, that is for yourself. If you any doubt, you can send me. If you like this lecture, you subscribe me. Thank you. Okay, good day.